and today I'm going to present with you my exercise on MCP. And as I wanted to try using multiple servers, I have created one server that has this sentiment classification tool and another server that has web search, roll dice, and text-to-speech. Let's look at the servers. In custom server.py, we have this sentiment classification tool. We are using FastMCP to create these MCP tools, and we are connecting to the Hugging Face hub for this Roberta-based model that is going to be used to classify the sentiment. And on the other hand, in server.py, we are using as clients Tabili for web search, 11 Labs for text-to-speech, and Roll Dice that is using the Dice Roller class from Dice Roller. So as I want to show you how the text-to-speech works, I have already the server running with uvrun server.py, and let's ask Cursor to, for example, create an audio of 30 seconds approx about MCP. So now Cursor is going to use the MCP tools, and we can see here that it has generated the file. So it's going to take a little bit for the speech file to complete, and here we have it.
Model Context Protocol, or MCP, is a revolutionary framework that enables...
Okay, and for the other part, I also wanted to create a LangGraph agent that uses these MCP tools. And what I have thought about is to use this LangGraph agent to retrieve documents for this PDF file. So when the users ask a query, for example, if he doesn't understand something about the policy of my company, we can retrieve the documents and we can generate a response and generate an audio for that response. We have also a conditional edge because we only retrieve documents if the user is dissatisfied with the service, doesn't understand something, or has a doubt. In the case that the user is satisfied with the service, we retrieve a predefined response. So as always, how I implemented this, we have our agent state, we load our PDF file, we chunk, we instantiate the embedded model, the quadrant database, we add the documents to the vector store, we instantiate this database as a retriever, we have here the rack chat template, we generate our generator chain, and here the interesting part is that we are setting up our multiple MCP client. We are using both servers, server.py and custom server.py, and we instantiate the tools from this client in asynchronous mode. Then we create an agent because we need an agent to execute these tools. So next we define our node functions, the classify sentiment node that takes the state, from the state the question, executes the agent on the question to get a response. And here the only thing we are doing is taking the sentiment from the response, that is two verbose. Next, we have the retrieve documents node, the generate response node, as always, and the generate audio node. And lastly, what we are we doing is extract the file name from the verbose response of the agent. And we have, as we have said, the conditional, the function for the conditional router, and we build the graph. And lastly, we put an example to run this graph. So I have used one negative query and another positive query. And let's stop the server and let's run it to see what do we get. So here is running. We have loaded the documents. We have set up the MCP client. We are testing the negative sentiment. We have retrieved the documents for this negative sentiment. We are generating the response with the unchained expression language chain, and we generated the audio that we have it here to respond to the user. And now the next step is the same, but with the positive sentiment. We are going to do the same. Classifying the query, it's going to classify it as a positive sentiment, and we do the same, generate the response and generate the audio. So that's it. I hope you have enjoyed, and see you next time. Bye-bye.